This is the third in the series for this topic. Today we're going to learn about the square root function. Okay, today we're looking at the graph of y equals root x, and then we'll be looking at the general form over here where we've got the transformations involved, where a once again is our dilation from the x-axis. There's a translation. B, it's inside the function. Here the function is the square root function. And we've got plus c on the end is also a translation. That's in the y direction, and the b is the translation in the x direction. And the dilation a equals the dilation from the x-axis. So that's how we should be remembering these three things. Okay, so we've got the values for the rule here, y equals the square root of x worked out for us already. Let's see how this has worked out. The first one, if we try and put x equals -2 into the rule, we end up with y is equal to the square root of -2. It's impossible using real numbers to get the square root of a negative number, so we say this is undefined. So this function here, square root of x, we're only defined for values where x is equal to 0 or greater. Because we can do the square root of 0, here the square root of 0, x equals 0 in the rule, the square root of 0, which is equal to 0. So that's the first point we can plot here. That's actually the starting point of this graph. Okay, so sometimes we call that an endpoint, so that should always label the endpoint of a graph, so 0, 0. Okay, if we put 1 into the rule, it becomes the square root of 1, which is 1. So that's the square root of 1 is 1, so we can plot the point where x is 1, y is 1. Okay, if I put 2 into the rule, we get the square root of 2. Square root of 2 is a surd. We can approximate the value. It's approximately 1.41. So it's going to, when x is 2, y is about 1.41, just about there. I'm going to skip 3 and we'll go up to 4 because we know the square root of 4 is equal to 2. So when we put 4 into the rule, we get 2 as an answer, so it goes through this point here. When we put, I'm going to skip 5, 6, 7, 8, put 9 in the rule, we get x equals 3 because the exact square root of 9 is 3, so it goes through this point here. And the last value here, the next square number we're looking at here is when x is 16, y is equal to 4. So it's this coordinate up here. So this curve, the square root graph, looks like this, goes through these points. It's one smooth, continuous curve. A bit hard with the mouse to get through exactly those points. On the next slide, we'll see a much better curve and show you exactly what it's supposed to look like, but it should be a smooth, continuous curve. So initially it goes up steep and then looks like it's flattening out. But keep in mind the graph is always, as it's going out here, as it's going out, it's always going up. Okay, so it doesn't bend down on itself. From my graph drawing with the mouse, it doesn't give a good picture of that. Alright, if we move on to the next slide, we can see what the graph should look like here. So you can see it's a very smooth, continuous curve. Goes through these key points of 1, 1 is a key point. 1, 1 seems to be a familiar key point of a lot of graphs. And square root of 4 goes through 2. So when you're looking at square root functions, it's often used to think what numbers are going to make a nice answer in terms of about a surd involved. So in this case here, if we use the square numbers, 1, 4, 9, 16, we can see it goes through those points. So once again, you see the graph starts down here at 0, 0. So we should label, make sure it's labelled 0, 0 because it's what we call an endpoint. That's where the graph starts. Steep in this first section, and then seems to flatten out a bit as we go this way. But once again, keep in mind the graph is always going up as it's going out. So the graph eventually will get to positive infinity, but not yet. Alright, so we say the domain of this graph is the smallest value of the x that we can use is 0, but we can use 0, so put a square bracket, 0, comma, and there's no positive number I can't put there, so we can go all the way out to positive infinity, so that's our domain. For the range, it's the same argument. We're starting at the lowest value here is 0, square bracket, it's equal to 0 there, and it keeps going up slowly, but will eventually hit infinity. It takes a long time, not like a parabola or a cubic, which heads out like that. Gets much higher quicker, but the square graph will eventually get there. It's still, the thing I want to remember is it continually goes upwards as it goes outwards. It doesn't turn back down on itself. Okay, that will do us for now. In this example, we're asked to sketch and also state the domain range of this following graph. So when we look at this graph here, which is y equals the square root of x, take 1 plus 2, we can see there's no dilation number at the front here, so it's still the standard shape for a square root graph. But this negative one here is going to cause a translation, 1 unit that way, and this positive 2 here is also going to cause a translation, but it's going to go up 2. So I'll just say 2, 1 there. Alright, the way we sketch these graphs is to think about what the standard square root graph looks like. So the standard one starts down here at the origin, goes through 1, 1, goes through 4, 2, and goes through the coordinate 9, 3. Okay, so what we've got to do is think about, here's the graph square root of x, or something along those lines. That's not the graph we're required to do. Our graph we want is that graph that's been translated 1 unit to the right and up 2. So each of the points that we mark here has to go across 1 and up 2. So the graph is going to begin at this point here, at the coordinate 1, 2. This point 1, 1 is going to go across 1 and up 2, so it's going to go through this point here, 2, 3. The coordinate 4, 2 is going to go across 1 and up 2, so it's going to get to this point here, the coordinate 5, 4, and the coordinate 9, 3 is going to go across 1 and up 2, so it's going to become the coordinate 10, 5. So every point's been raised up 2 units and translated 1 unit to the right. So now we can try and draw our square root graph through these points. My efforts with the mouse aren't that great. I'm trying to draw curves, so it's going to be generally that shape. So you get an idea what it's going to look like. What's the domain of this graph? Well, the x values start at 1, so we say it's square bracket 1, comma, to infinity, because it keeps going out there, and no value of x we can't put into the rule from above 1. And the range, what's the lowest value of the y's here, is 2, and it's equal to 2, so we use a square bracket, and it goes up to positive infinity, just slowly. If you look at the next slide, we'll see a better version of this, which I'll click over to now. So here you can see that those 3 of those key points are marked out. I've marked in this point here, which is the coordinate 2, 3, goes through. But there you get the idea, and there's our domain and range written down the bottom. Thank you. We'll proceed to the next example. Right, first thing you'll notice when we look at the rule here that we've got the number first and the function part second. So when we get this situation, the first thing you should do is rewrite the order. So the square root function goes first, but keep in mind there's a negative in front of it. So we write it like this, negative square root of x plus 1, and that 2 has a plus sign in front, so it's plus 2 on the end. Okay, as we've seen before, putting a negative at the front of a function causes it to be reflected in the x-axis. Plus 1 inside the function causes a translation of 1 unit back to the left. and a +2 at the end causes a translation up of 2 units. So because the square root graph's been reflected, keep in mind the graph is going to look like this. So I do keep that in mind, that's what the graph's going to look like. So we do the reflections before translations, so graphs like that. So we've still got that starting point 0, 0 at the moment, but now I'm going to do my translations. We said here it's going to translate 1 unit to the left, so it's going to go this way across here, and up 2. So the starting point of the graph is going to be here. So we go up 2, 1 to the left, up 2. So this graph's going to start here, and it's going to come down like this. I'm not too sure where it's going to cross here, but I could use the fact that this point here is the point when x is 1, y is -1, because on the original graph, the square root graph, it went through the point 1, 1, and when we reflect it in the x-axis, which is here, it becomes 1, -1. So if I got the point 1, -1, and I go 1 to the left and up 2, I can see the y-intercept is going to be +1. So I'm just going to label these coordinates. I've got the coordinate -1, +2, and I've got the value here when x is 0, y is 1. We could have done that by working out the y-intercept by putting x equals 0 into the rule. Y-intercept, put x equals 0, get negative square root of 0 plus 1 plus 2 on the end. So this should be y equals. So y equals the negative the square root of 1 plus 2. We know the square root of 1 is 1, so this is -1 plus 2. And we get the answer 1. So we found 2 different ways to find that y-intercept. The graph comes down like this. It's going to cross the x-axis because it keeps going down. So how do I find the x-intercept? I try and solve the equation where y equals 0. So the x-intercept is going to be, when I have this equation here, that the negative of square root of x plus 1 equals, plus 2 equals 0. So the first thing I do is take the 2 over the other side, so I've got negative square root of x plus 1 equals -2. By both sides of that negative 1, we've got the square root of x plus 1 equals now +2. Set operation of square root is to square, so then if we get rid of the square root by squaring both sides, x plus 1 equals 2 squared, which is 4, and take 1 from both sides, get x equals 3. So my x-intercept is actually this point here, the coordinate 3, 0. So this is going to be very hard for me with the mouse to draw this properly, but basically the square root graph is doing this. And it's supposed to go through the x-intercept there. But like I said, it's a bit difficult with the mouse. On the next slide, we'll see the proper how the graph should look. Let's do the domain while we're here. The domain, the lowest x value I can use is -1, and it's equal to that, so I go square bracket -1, and it goes out to +infinity. The range here, we go from the lowest y value, because it's actually going down to -infinity, so it's round bracket -infinity, up to the most positive y value of this graph, which is 2, and it's equal to 2, so we use the square bracket. So we'll proceed to the next slide and we'll see how this should look. Right, there's a better version of it, and you can see that it starts at the point -1, 2, comes down through the y-intercept of 0, 1, and the x-intercept of 3, 0, and continues on that path going downwards as it's going outwards. Okay, that's a good place to stop this slide. Hi, again, this is a demonstration how to use our calculators. I've prepared a got here called my square root graphs or root graphs. We go to look here, got the form of the general form here, where A is our dilating factor from the x-axis, B is our translation from the x-axis, and C is the translation along the x-axis left to right, and C is the translation up or down. Okay, I've set my sliders A as 1, so no dilation, B and C as 0, so there's no translations yet. So we can see here I've got a couple of key points marked. Starts at 0, 0, goes through to 0.11. You can see way out here, goes through to 0.93. You can see it goes through to 0.42. So there's some standard points. Okay, so if I change A to 2, you can see now the graph is twice as high as it was previously. But you notice the point was on the x-axis, stays on the x-axis. Multiplying the y value 0 by any number is still 0. Here the original y value was 1. The point becomes 1, 2. The point that was 4, 2 now becomes 4, 4. It's twice as high. And the point 9, 3 now becomes the point 9, 6. And we'll put A back to 1. Let's have a quick look at what B and C do. So if I make B a positive number, it translates the graph 1 unit to the right. If I make B 1, if I make it B3, translates 3 units to the right. If I make B a negative number, effectively that means x take a negative, or look in the rule like x plus a number. So this graph here, where B is negative 1, is actually the rule y equals the square root of x plus 1. Once you translate the graph left or right, you have to work out what the new intercepts are. If it moves to the left, then you'll create a y-intercept. If it moves to the right, the x-intercept is the thing you need to calculate. If we take a look at what y does, if we make C positive, translation in the y direction, moves the whole graph up 1 unit, so you may not have an x-intercept by moving the graph up. So there, if I move the graph down though, you're going to get both a y-intercept and an x-intercept, depending on what you're doing with B as well. So I'm just going to put C back to 0, and let's see what happens when I make A negative. So making A negative causes the graph to be reflected in the x-axis, so this is our mirror line, the x-axis, but A still does its dilating effect. So if A is negative 2, it's reflection in the x-axis and a dilation effect of 2. So the two graphs we just looked at, the first graph was when A was positive 1, the first example. B had the value positive 1, and C had the value positive 2. So shouldn't say 2.1, shouldn't say 2. Don't know what's happened there. And that's the graph that we drew. Remember always you can have a look at a table of values of these things. So when x is 1, y is 2, and you get some whole number values every now and again with the square root function. Right, note here that because the rule was square root of x take 1, 10 created a nice number because taking 1 from 10 makes 9, and we made the square root of 9. Alright, if we go back to the graph here, the second graph we drew earlier was when A was negative 1, B had the value of negative 1, and C had the value of positive 2, which is what we've got there. Let's move this label up here. This label intercepts that way. We can see we've got the y-intercept of positive 1, so 0, 1. The x-intercept is 3, 0. The endpoint here is not marked, which needs to be marked. So like these calculators, you've got to actually put the points on yourself. I might just show you how I can put that point on there if I wanted to. So I go to menu, go to geometry, go to points and lines, go to point on. So I see which graph I want to put on. I'm going to put on this one here. And just click somewhere there. It doesn't matter which value I put. Why this little icon's up in the left hand corner is the point on. I can't do anything except put points on the graph. I need to press the escape button. And then I'm just going to move this label up to here so we can see that. if I click inside there and just change the number to -1, it'll change the y value because the point is on the line, so it's going to follow the rule. And there I get the endpoint. So that's 0, 1 belong down there. So this red point is when x equals 1, that's all. It doesn't mean it's going to, if x equals 1, then it's going to be 2 minus root 2, which is roughly about 0.58. So that's how you get the calculated draw the best value. Thank you.